Okay, good morning, everybody. I hope you guys are doing well. I am going to discuss the second set of exponent rules that we covered in Chapter 7, which came from Chapter 7, Section 2 this time. So here are the four. There were actually four. Here's the first one. It was called the quotient rule. And the quotient rule was if you have a base and a power and the bases match and they're being divided, you subtract their powers. The next property that we discussed was called the power of a quotient. It's very similar to a power of a product in that if you have two things that are being divided and the entire expression is being taken to a power, that power would distribute to everything inside the parentheses, no matter whether the stuff is on the numerator or the denominator, everything is going to get that power. The third property that we discussed in Chapter 7, Section 2 was called the zero property, meaning that anything to the zero power is 1, no matter what. That one's a fairly easy one. The last one that we discussed is the negative power property. Now, this one is a little trickier just because it can show up kind of in two ways. In this particular case that I'm showing you, if you have a base to a negative power, you put a 1 over it, and the base and its power go to the denominator of the fraction. Notice that the power itself then becomes positive. Now, this one shows you something going from up here to the bottom. Also note that this can work if you have something in the bottom of a fraction and the power is negative, it will go up top. I'm going to show you a specific example of both of those here in one second. Okay, so let's look at the quotient property a little more in depth and give you a specific example of that. So the one that I come up with was z to the fifth divided by z to the second. As you can see, both of the bases of the power are both z, so they're matching. That has to be the case if you're going to use this property. And because they are matching, you are simply going to subtract the two powers. You'll have z to the 5 minus 2, which turns into z to the third power. That's the quotient property. The next rule that we had from Chapter 7, Section 2 was the power of quotients. And as you can see, when you have, now notice the bases are different in this case, which is why they can't be combined. But what I do want you to see is that the 6 on the outside would distribute to both the x and the y, and therefore you would get x to the sixth, y to the sixth. And no, they would not subtract or do anything else beyond this because the bases are different. The next property that we had was the zero property, and this one was fairly easy. I think you guys remembered this one. It doesn't matter what you have in the set of parentheses. There's a 2, there's an x to the first, a y to the third, even a z to the negative 2. All of that is being taken to the zero power, and because all of that is being taken to the zero power, anything to the zero power is 1. So the answer to this would be 1. The last property we're going to look at today is the negative exponent property. And in the general example that I showed you at the beginning of this discussion, that we have a negative m right here, which brings the whole base and the power down to the bottom of a fraction. So that's what this one's going to do. We have 2 to the negative fourth. So then it will become 1 over 2 to the fourth. Now we can evaluate this a little bit further and we can think about what 2 to the fourth would be, which would be 2 times 2, which is 4, times 2 is 8, times 2 is 16. So that gives us 1 over 16. Now I did want to give you a second example of this where the power on the bottom has a negative exponent because this property also works in that if there's a negative exponent, the base and the power need to switch positions. So you can see up here, this would be on the top of a fraction, it moved to the bottom. Over here, this is negative, but it's on the bottom, so it is going to move to the top. So this will actually become 3 to the fourth. and 3 to the fourth. 3 times 3 is 9. 9 times 3 is 27, and 27 times 3 is 81. So that becomes 81. All right, everybody, that is concluding the second set of exponent rules that we learned in Chapter 7, Section 2. I hope you're all are doing well. And if you wouldn't mind trying these practice problems on the Chapter 7 review worksheet, I would like you to complete numbers 1 through 3, 5, 6, 9 through 11, 13, 18, 20, and 21. All right, take care, everybody. As always, if you have any questions, please feel free to email me at mccalls@sasd.k12.pa.us.